Hi. People often ask the question why electronics transformers such as these aren't being read properly by multimeters. I have a 10 60 watt electronic transformer here, a 20 60 watt electronic transformer here, and a 0 50 watt electronic transformer here. So that's got 10 watt minimum load, 20 watt minimum load, and there is no minimum load for this one. So this is a selection of three which I'm going to use on these various multimeters. This mess of wires over here is really just to connect this whole thing together, so pay no attention to that. All you're really interested in is the multimeters. I've got an 80s multimeter here, a cheap multimeter, roughly about £25, a workhorse multimeter, which is often what you would see with a lot of technicians. This, which is a workshop multimeter, which you tend to find in electronic workshops, repair and so forth. This is of a budget which is roughly about 10 to 20 times more than the budget multimeter, which has got a hell of a lot of functions. I mean, it's very good value for money, modern multimeters, but it really is in a completely different league. The bench multimeter here is, again, this is something that you would expect more in the laboratory, and it's highly accurate but very focused in what it can do. So anyway, I have a selection of multimeters here. I have a passive electronic transformer, and this is a 12 volt halogen transformer, and you can see all the transformers are reading quite happily 13.5 volts. It's a 12 volt transformer, but it's reading slightly high. Here I've got an oscilloscope, and the oscilloscope quite nicely has, quite conveniently, these cursors, so you can see the get an idea of exactly what the range is on this just by visually. So what I want to do is just show you that this is, in this particular country, it's 240 volts at 50 Hertz and 20 microseconds, which is basically one wave, so it goes so forth, and that's 20 microseconds, and that's 50 Hertz. So it's just to give you a visual idea of what you would be seeing if you were looking at 50 Hertz. This is just to give you an idea of what you're going to be seeing in a short while. So I'm going to add a 20 watt load to this transformer, and you'll notice that all the multimeters are roughly about 12.8 volts, and they're quite happy. They seem to be reading that. I'll just put this back to what I've got this set to. These cursors is 33.9, which is that for a perfect sinusoidal wave you would expect that the peak to peak voltage is 33.9. so even though these are measuring 12, as I said before, that's how you would calculate RMS, so it's perfectly acceptable. So let's take a quick look at a 50 watt load. And you can see that all of them are reading roughly about 11.9 volts in that region. So again, this is what you expect, 60 watt with a 50 watt load. It's going to be this ballpark, so I'm quite happy to say that that seems to be working as expected. So let's take a look at the first electronic transformer. This is a 20 watt minimum load transformer. and we can see that we're running into trouble already. The waveform is nowhere near the 12 volts, it's some spurious, weird looking waveform. The laboratory multimeter is 3.6 volts, the RMS is 3.4 volts, so these seem to concur. But 1.2 volts, 0.1 volts or 0.2 volts, 0.07 volts, these don't seem to be reading anything at all, really. So the first thing it looks like is this is broken. So let's put a load on it. And clearly it's not broken, because it wouldn't light up otherwise. But you'll see that the waveform is now kicked into life, and it's quite a strange looking waveform. You'll notice that the old multimeter, the cheap multimeter, the workhorse multimeter are again giving me 5.6 volts, 0.8 volts, 0.3 volts, but this is 11.6 volts and this is 11.66 volts. Looking at this between the cursors, I can see that it looks roughly below the 12, but roughly in that ballpark. So let's take a look a little harder at the waveform, and we can see a rather interesting bunch of, it's made up of multiple frequencies, and actually you'll find that this goes from about 100 meg for the smaller to the about 40 odd megs. So let's just look at the frequency from this, and we'll see that the fundamental that this is picking up is 42, which is probably the vast majority of the larger waves. But let's go back. And we'll just look at the time, and you can see that those two, so this is the sine wave and it's modulated 41 kilohertz over the 50 hertz. So that's what we kind of look at in this particular scenario. Just to note, do not handle halogen bulbs like this. They're not getting hot in this particular case because I'm doing it quite fairly quickly. But you will get burned if you aren't careful with these things, so don't do as I do. In this particular case, we can see this is 31 kilohertz. These three, again, they're not reading anything. 9 volts, 1.6 volts, 0.8 volts, but 11.5, and if we look at this one, 11.6. So these are reading. That's a 50 watt halogen. Let's take that off. And the important thing to note is that the load allows the frequency to be generated within the electronic transformer. So when there's no load, it appears to be dead when there's a minimum load. So let's take a look at the 10 watt. Again, we can see 1.6, 1.6, 0.02, 0.05, 0.3. So again, doesn't seem to be working, and that's the first thing. Generally speaking, when people don't load these things, they just measure the output. There is no output. Well, there is an output, but it's a spurious output. If we put this under load, and this is a 20 watt, we can see it jumps back into life, and 11.9, so they're quite close to the cursors, so that's exactly what I was about. 12, 11.5, but 0.06, 0.2, 9.2 doesn't seem to be giving me any sensible values. 50 watt. Again, we're seeing an output, looks roughly what we would expect for an electronic transformer. complicated wave shape, an envelope, modulated envelope of a fundamental of 51 in this particular case, and these three are not giving any sensible readings. This is giving 11.9 and this one here is 11.7. So let's look at the last one, and this has a 0 watt minimum load. And this is kind of something that is almost a dual. You can run halogens off this and also LEDs, because sometimes the LEDs are just not sufficient if you're to power the others. But I'll do another video on LEDs to make that a little bit more clear. So you can see that it's now giving an output, so there's no load on this. You can see that this has got quite a good reading, 12 points. Let's just look at the frequency of that, 29. And but it's given me the voltages that I would sort of expect. So 13.4, 12.9, well, that looks a little bit out, but they look about right for what I would expect. So let's put it under load. The wave shape's changed slightly and it looks more like the electronic transformers that we saw before, but because this generates its own frequency, this frequency doesn't change. And we didn't look at the others, the other frequencies, I don't believe, but the frequencies tend to move around, whilst this is consistently roughly about 20 kilohertz. And if we were to look at the again, we would see this is much more consistent in the actual frequency, because the frequency is a single frequency. It doesn't change depending on what the load is. So let's see, this is a nice looking, you can see it's pretty consistent, unlike the previous. There is a frequency change as the waveform gets smaller, but all in all, it's what we would see as a single frequency. So let's go back to this, and we can see that if we take out the 20 watt and put in the 50 watt, again, this is reading 12.1, 12.4, this isn't reading anything. This is reading 1.4 volts. This is 0.7 volts. That's 9.11, just in case you didn't actually see that. So hopefully this video is going to allow you to see, or has allowed you to see, what you would kind of expect if you're using these sort of multimeters, which is what you would usually expect the average person to get hold of, whilst these are usually in a budget which is beyond. You can pick these up second hand, but generally speaking, we wouldn't expect, or you wouldn't generally expect to have these sort of multimeters, but because the frequency is high and the waveform is quite complex, these tend not to be capable of dealing with that. So I hope this goes to help, and I shall do another video at some point about LEDs and electronic transformers.